The Suez Canal was open again. Ships were moving through. 6 days of blockage were over. But the ships coming out were no longer spaced the way their services had been planned. For days, vessels had accumulated on either side of a canal blocked by the Ever Given. Once it was cleared, the waiting ships could move. The queue could shrink. If the blockage was the problem, the schedule should now start catching up. Except reopening the route only released the ships. It did not put them back where they were supposed to be in time. The canal was open. The schedule was not. So what was still broken? A container ship is not usually one isolated trip. On many major liner services, several ships repeat the same sequence of ports. One arrives, another follows behind it, then another. On major routes, that cadence is commonly built around regular, often weekly calls. What matters is not only where the ships go, it is the gap between them. That gap gives terminals time to handle one arrival before the next. It helps cargo owners plan around expected calls. And where containers need another ship to continue their journey, it helps those connections line up. A small delay can often be absorbed. But if several ships are delayed together, those gaps begin to change. Now the problem is no longer just that the ships are late. They are starting to lose their positions relative to one another. Shipping schedules have some give. Ships can adjust speed. Terminals can revise berth plans. Schedules carry some margin for ordinary weather, traffic, and operational delays. That is why many small disruptions are absorbed. A large, shared disruption is different. At Suez, vessels approaching the same choke point stopped for the same reason. Instead of continuing along the route at their previous intervals, they accumulated. Then the canal reopened. The obstacle disappeared. The old spacing did not. Some gaps between ships had collapsed. Others had stretched. The blockage had ended. But the timing distortion it created was now moving downstream, toward the next ports. A terminal can handle a steady stream of ships very differently from a compressed wave of them. The total traffic does not necessarily have to increase. It can simply arrive in a much narrower window. And a port has to deal with what arrives at the same time. There are only so many berths, only so many cranes, only so much yard and handling capacity available at once. Terminals can revise their plans as arrival times change. Late vessels are not automatically locked out just because they missed some universal slot. But planning cannot make physical capacity infinite. So when delayed ships arrive together, another queue can form. Ships wait. Turnaround can slow. A vessel that was already late can leave later still. Congestion does not always mean more traffic overall. Sometimes the same traffic simply arrived at the wrong time. At this point, the explanation seems almost complete. Work through the wave, clear the port, let the ships catch up. Except a ship can finally arrive, and some of its cargo can still get later. A ship can finally arrive, and some of its cargo can still get later. At a transshipment hub, some containers leave one vessel and continue on another. That onward service has its own departure time. If the mainline ship arrives too late, the vessel it was supposed to connect with may already have sailed. The main line can reach the berth, it can unload, it can continue to the next port. The container stays behind. It may wait for another suitable sailing, or it may have to be rerouted. Depending on the connection, that can add days beyond the delay of the original ship. And while the container waits, it remains in the terminal and has to be handled again. The ship has arrived. The connection has not. The delay has moved. It no longer belongs only to the vessel that first carried it. Now it exists between two services that no longer meet at the right time. And at this point, the obvious solution seems simple. Make the ship faster. Sometimes that helps. Ships can speed up, On a long ocean leg, extra speed can recover part of a delay. But those recovered hours only matter if the next part of the journey can use them. If the berth cannot take the ship earlier, some of the time recovered at sea becomes waiting time. If the onward vessel has already departed, arriving faster afterward does not bring it back. And if several delayed ships are all converging on the same port, moving every one of them forward does not recreate the spacing they lost. It can simply move the bunching forward too. Higher speed also means higher fuel use, so there are economic and environmental reasons not to run faster than necessary. Speed is a real recovery tool, just a limited one. It can recover time on a leg. It cannot rebuild the whole pattern. Once the problem reaches that scale, operators have to change something else. For the teams managing a liner service, a badly delayed ship can leave two commitments that no longer fit together. There is cargo waiting at the next port, but keeping that call may carry the vessel's delay farther downstream. One option is to keep the call. The cargo there gets served. The vessel may remain late for the ports that follow. Another option is to omit the call. In some situations, that can remove enough waiting and handling time for the vessel to recover part of its downstream schedule. The vessel gets time back. The cargo tied to that port does not. Exports waiting there may need another ship. Imports may have to be rerouted. Some containers miss the journey they were originally booked to make. Operators can make other adjustments too. They can change speed, roll cargo onto a later sailing, revise port plans, or rephase the service itself. None of those choices makes the lost time disappear. Someone still has to absorb it. Protect this call, and perhaps remain late downstream. Recover the wider schedule, and some cargo may wait instead. That is the trade-off inside schedule recovery. By now, the original blockage may be long gone. What remains is the timing it disturbed. Ships that should have arrived separately may still be arriving too close together. Some gaps may be too large. Some onward connections have already been missed. So operators begin changing the pattern. Vessels are reslotted. Some time is recovered at sea. Some calls are adjusted. Some cargo moves on later or different services. The objective is not to put every ship and every container back onto the plan they had before the disruption. That moment has passed. The next cycle has to become predictable again. Ships need useful separation. Ports need arrivals they can actually handle. Onward services need incoming cargo to reach them within workable windows. Gradually, the arrivals spread out. Connections begin to line up again. The next vessel reaches a network that has room for it. Some cargo may still be late. A backlog may still exist somewhere. But the distorted timing is no longer generating the same kind of fresh delay simply because everything is reaching the next place at the wrong time. That is resynchronization, not a sudden reset. A return to a pattern the network can run again. Go back to the canal. It is open. Ships are moving